Welcome back to the channel. In today's video, we are going to explore bitwise operators in Python. Bitwise operators are used to manipulate bits in integers. They include AND, OR, XOR, NOT, and bitwise left shift and the right shift operators. Let's go and see each one with examples. The bitwise AND operator compares two numbers and returns 1 if both bits are 1, else it returns 0. Now let's see the example. We assume A equals to 10 and B equals to 6. The binary representation of 10 equals to 1010 and binary representation of B, that's 6, equals to 0110. We then perform A and B and the result is 0010. So the last one is 00 equals to 0, and if both bits are 1 then it is 1, else it is 0. And the decimal representation of 0010 is 2. Now let's go and practice in Jupyter Notebook. Bitwise and operator. So I'm going to create variable A equals to six here, and another variable B equals to 5. Then I'm going to print the binary value of A. So binary of A equals to, I'm using the function bin A. Similarly, binary of B, bin B. Now run the code. It will give the binary value of A 110 and B 101. And we'll create another variable result and perform AND operation between A and B, and then we print the result. Bitwise AND of A and B is result, and the result is 4, that is in the decimal value. Next we have is the bitwise OR operator, and in this case it returns 1 if any of the bit is 1, else it returns 0. Let's see the example. A equals to 10, B equals to 6, and as earlier, binary representation of A is 1010 and binary representation of B is 0110, and A or B equals to 1110. That means if any of the bit is 1, then it gives the result 1, and the decimal value of 1110 is equals to 14. Now we are going to practice in Python code. Has bitwise OR operator, enter A equals to 3, B equals to 5, and we are printing binary values of A and B. Bin A, print binary of B, bin B, and we run that. We'll get the binary value of 3 and 5, and then we create result variable and we perform A or B, and we print the result. Bitwise OR of A and B, those two result, and then we run the code, and the decimal value is 7. Here we have bitwise XOR operator. So in this case it returns 1 if one of the bits is 1, else it returns 0. And let's see the example. A equals to 10 and B equals to 6, and binary representation of 10 is equals to 1010 and the binary of B is 0110, and if we do XOR between A and B it gives 110, and the decimal equivalent of it equals to 12. Let's go and write some code in Python. Hash bitwise XOR operator. Let's create variable B equals to 4 and C equals to 5, and we are going to print the binary of B bin B and print binary of C bin C. We'll run and see the binary values. Yeah, binary value is like that, and we'll create another variable result and we do XOR B and C, and then we print the result. Bitwise XOR of A and B result. Then we run and the resulting value is 1. So this is how we calculate XOR in Python. The next operator is the Bitwise NOT operator, and in this case it returns complements of a number. And let's see the example. And if A equals to 10 and binary of A equals to 1010 and the NOT operator of A, that is 1010, is equivalent to 0101. It basically complements the number and the resulting value is the 5 in the decimal. Has bitwise NOT operator. Enter A equals 7 and print binary of A bin A, and we see the binary value of 7, that's 111, and result equals to NOT of A. While performing NOT operator, in this case it also considers the sign bit of the 111. So if we print the result, the value will be -8. Next is bitwise right shift operator, and it shifts the bit to the right. Let's see the example. A equals to 10 and binary of A equals to 1010. Here I have added 0 because it represents the sign bit and which represent the positive value. And if we shift the A by 1 bit, then our value will be 00101, and this is equivalent to the decimal value of 5. The last bitwise operator is left shift operator, and it shifts the bits to the left. For example, A equals to 5 and binary of A equals to 0101, and we want to shift the bit by 1 bit, then equals to 1010, and the decimal equivalent of 1010 is 10. Now let's write the code. Hash bitwise shift operator. Enter A equals to 8, and then we will print the binary of 8 equals to bin A, and we see the binary value. We'll create variable result and we will shift A to left by 1 bit, and then let's change to result 1, and result 2 will be right shift to 1 bit, and then we are going to print left shift of A result 1 and print right shift of A is result 2. Let's run this code and we get the result 16 and 4. So that's all for today. Thank you for watching and see you in the next video.